Welcome to Curiosity. Today, we explore the last message from humanity. In this explainer, we're going to unpack the truly fascinating science behind interstellar communication, the existential risks we currently face as a civilization, and what our ultimate cosmic legacy might actually look like. So let's just dive right into this profoundly chilling concept. It's an idea that sits perfectly at the intersection of astrophysics, cosmology, and, well, our own mortality as a species. It really addresses the core of the Fermi Paradox. If the universe is just so unimaginably vast and ancient, where is everybody? That deafening silence kind of implies that technologically advanced civilizations might actually be incredibly rare, or maybe their lifespans are just brutally short. By studying how we might send out our absolute final message, we're really engaging in the ultimate exercise of species-level self-preservation. Moving into part one, interstellar greetings, a history, because to really grasp what our final message might be, we first have to look back at our incredibly optimistic early attempts to just say hello to the cosmos.
These major milestones were championed by visionary scientists like Carl Sagan and Frank Drake, and they marked humanity's first deliberate efforts to leave a permanent mark on the universe. We kicked things off in 1972 with the Pioneer plaques, which carried these simple pictorial messages of the human form. Then, in 1974, we beamed the massively powerful Arecibo Message out from Puerto Rico. And of course, in 1977, NASA launched the Voyager Golden Records. Think of it as humanity's ultimate interstellar mixtape, packed with the diverse sounds, languages, and images of life right here on Earth.
To put our progress into perspective, consider the number 24 billion. That is the staggeringly massive distance, in kilometers, that Voyager 1 has traveled from Earth as of late 2023. That's almost impossible to wrap your head around. It became the very first human-made object to cross the heliopause into interstellar space, carrying our golden record deep into the void. Right now, it serves as our most distant physical ambassador. Which brings us to Section 2, Cosmic Communication, the physics. Because beyond just launching physical probes, actually transmitting a message across the sheer vastness of the galaxy is fiercely constrained by the fundamental laws of physics. Let's look at the harsh scientific realities of actually making ourselves heard. You see, space is incredibly noisy. It's absolutely flooded with the cosmic microwave background and stellar radiation. So to even be heard, a message has to be sent on a very quiet frequency. Scientists actually identified a sweet spot known as the water hole. It's this highly specific radio frequency band situated perfectly between the emission lines of neutral hydrogen and the hydroxyl radical. Put those together, and you get the exact chemical components of water. And since water is so universally essential for life, scientists hypothesize that any communicative extraterrestrial civilization out there would just naturally be monitoring these exact quiet frequencies. But here's the major hurdle, the inverse square law. This mathematical reality basically dictates that a signal's intensity exponentially drops off as it expands outward into space. To be specific, its intensity is inversely proportional to the square of the distance from the source. It fades fast. Because of this really harsh constraint, a message either has to be beamed with unimaginable, mind-boggling power, or it has to be tightly focused, kind of like a laser, just to remain distinguishable from all that cosmic noise over thousands of light years. So, assuming we can actually reach them, how do we even speak to them? Human languages are completely useless out in interstellar space. Instead, mathematics steps up as the true universal language. We encode our messages in binary code, just simple zeros and ones. And to overcome that cosmic noise and prove without a doubt that the signal comes from a genuine intelligence, the message is usually preceded by a sequence of prime numbers, 2, 3, 5, 7, 11. Natural phenomena like pulsars, they simply do not emit prime number sequences. It makes it an absolutely unmistakable artificial signature. Let's transition to part 3, modern tech and future messages. We're going to see how these unyielding physical laws directly shape the technologies we're actively developing today for METI, which stands for Messaging Extraterrestrial Intelligence. When sending a signal, we basically face a choice in our transmission mediums. Now, radio waves have traditionally been the go-to because they can easily penetrate dense interstellar dust clouds. The downside? They spread out heavily over vast distances and require simply enormous infrastructure like the upcoming square-kilometer array. In contrast, a lot of recent advances are actually pointing us toward optical or laser SETI. By using intensely focused, high-powered lasers, we suffer way less diffraction. In fact, a short, highly targeted laser pulse can temporarily outshine a literal star by a factor of thousands, cutting brilliantly through the dark. And I want to emphasize, these aren't just fun thought experiments.
Our cosmic neighborhood has been mapped with extreme precision, and we are actively targeting specific exoplanets located right in their stars' habitable zones. While the original Arecibo Message will take tens of thousands of years to reach the M13 cluster, newer broadcasts are much closer to home. For instance, a message from Earth directed at Gliese 581c and the sonar calling message beamed to Luton's star are actually going to be arriving at their destinations within our lifetimes, specifically in 2029 and 2030. That is just right around the corner. However, this leads us right into Section 4, the dark forest, a cosmic dilemma, because actively choosing to send these messages out introduces some pretty unprecedented scientific, ethical, and philosophical hurdles. This brings us to a frankly terrifying astrosociological concept known as the dark forest hypothesis. It essentially poses that the universe is like a pitch-black forest, where every single civilization is an armed hunter quietly stalking through the trees. If a civilization reveals its location by broadcasting a message, it risks immediate annihilation by a more advanced, preemptively defensive species. So think about it. If humanity were facing its inevitable end, should we broadcast our coordinates and our legacy into the void, or should we remain absolutely silent, hoping to avoid triggering a strike on whatever biosphere remains?
That dilemma is deeply tied to the concept of the Great Filter. This is a proposed solution to the Fermi Paradox, suggesting that there's an evolutionary or technological threshold out there that is almost impossible for any civilization to cross without completely destroying itself. If humanity is currently approaching our own Great Filter, maybe through existential threats like nuclear proliferation, extreme climate change, or unaligned artificial intelligence, well then crafting our last message goes from being a neat theoretical exercise to an absolute statistical inevitability. So the really crucial takeaway here is that a truly permanent legacy simply cannot rely solely on radio or laser waves. Electromagnetic broadcasts are incredibly fast, zipping along at the speed of light, but they're fleeting. Due to the expansion of the universe, they'll eventually stretch out, redshift, and just fade completely into the cosmic microwave background radiation. Physical artifacts, on the other hand, they are painfully slow to travel, sure, but they are capable of surviving for billions of years. They could literally outlast the stars themselves. And that is exactly why modern scientific efforts are pivoting. While the breakthrough initiatives map out how to design the ultimate signal, organizations like the Arch Mission Foundation are turning to highly durable physical mediums. They are actively developing these microscopic Superman memory crystals made entirely of quartz silica glass. These little devices are unbelievable. They can safely archive terabytes of human history, literature, and biological data, pretty much ensuring our story survives for billions of years, long after our electromagnetic whispers have faded away. Looking even further forward, theoretical physics suggests our final archive could take on entirely new, mind-bending forms. Someday, we might deploy von Neumann probes. Imagine AI-driven, self-replicating spacecraft that travel to a star system, mine the local asteroids for materials, build exact replicas of themselves, and just spread exponentially across the galaxy. Or, building on the success of LIGO, incredibly advanced civilizations might artificially generate actual gravitational waves, broadcasting messages that ripple unhindered straight through dust in planets. Quantum communication is also heavily researched, though for now it's held back by the no communication theorem, preventing faster-than-light classical data transfer. Bringing it all home to Part 5, a mirror to humanity, our cosmic reflection, because ultimately this entire endeavor is about so much more than just reaching out to extraterrestrials. It acts as a critical mirror, reflecting our current state as a species. Preparing a final message truly forces us to confront our own incredible fragility. But there's also a profound beauty in it. Even if no one ever answers us, even if absolutely no one ever hears it, the very act of sending that final message represents the ultimate triumph of the human spirit. It is an act of sheer defiance against cosmic entropy. It's a testament to that deep, fundamental desire to declare into the vast, dark void, we were here. Which leaves us with this final powerful question. Will our ultimate cosmic message be frantically forced out tomorrow by a great filter we just failed to cross, or will it be broadcast in the unimaginably distant future by a thriving humanity? Contemplating this finality really highlights the urgent need to navigate our existential threats today, just to ensure that our story in the cosmos is far, far from over. Thank you so much for joining me for this explainer. Keep your curiosity alive and always keep looking up.